McElroy and I run the sustainability programme for Archtecture+Design Scotland. We're really pleased to have been asked to be involved in this event for World Green Building Week. And in a moment I'll hand you over to Dawn McLean, Managing Director of IES, who will outline the role of performance analysis in addressing the key challenges for sustainable design. First, I'd just like to say a wee bit about NDS. This is not a kind of traditional arena for NDS to be involved in, but Archtecture+Design Scotland is Scotland's champion for excellence in placemaking, architecture and planning. And our role is to advocate a better understanding of the importance of good quality design in both buildings and the public realm. And in doing this, we work with a very wide-ranging audience of all ages, from the general public to building clients, designers, constructors, and those responsible for the creation and implementation of national and international design standards and codes. We have 5 programme streams: urbanism, school design, healthcare, design review, access to architecture, which is our exhibition programme, and SUS, the Sustainability and Architecture programme, which I run. And the role of the sustainability team is to facilitate the delivery of sustainable buildings and places. And I'm therefore delighted that we're hosting this event for World Green Building Week, as for some time I've been advocating a more proactive role within our organisation to link the work that we do more tangibly with the delivery of a greener, low-carbon Scotland. I admit that I'm totally biased in this, in that my background is in the delivery of tool-based building energy and environmental design support. But nonetheless, I see this evening as an opportunity for my organisation as well as for all of you. The possibilities are perhaps more obvious at a building level, but there's also a need for greater use of performance analysis at a city level. And on that note, I would recommend a visit to our latest exhibition, City Visions 1910 to 2010, once the formalities of the event are over. So thank you all for coming, and I'll now hand over to Tony.
What I'd like you to do is, I'd like you all to imagine you're an airplane, okay? And I'm the captain of the aircraft, and I'm going to speak to you over the camera, okay? And when you're on the airplane, you're buckled up, and I said also to raise your hand, and that means that you're on the plane. And as I'm talking, when you want to go off the plane, just lower your hand, okay? Now, there's no trick here or anything like that. I just play the game genuinely from that side of things. So, could I please ask you all to raise your hand? Okay? And when you feel uncomfortable, just lower it, okay? Welcome to the maiden flight of McLean Airlines. I've done some hand calculations, and I'm fairly sure this thing will fly. The guys that you see walking around with the ratchets and things like that, they'll just make sure that the thing is still, they will be able to go off the ground okay. I'm not sure if this thing will land, because we've not done any testing. Now, wait a minute. One guy, one person get their hand up. Look at this from a building perspective. When people design buildings, they don't know how it's going to perform really. They don't know how it's going to operate. Okay? What building simulation is about is giving you the information that allows you to understand what will happen and design an object that will actually suit the people that are within it, but most importantly, do it in a sustainable and low energy way. Okay? So that's what we're talking about today. We're talking about building simulation. Okay. So what's building simulation about? It's aimed at allowing people to quantify, optimize, and verify the simulation. That's what it's about. It's to give you information to empower you from that side. I travel around the world talking about simulation and things like that. I can tell you right now that the UK leads the world in this area. Okay? We're way ahead of the States. I reckon the States are probably about 5 to 10 years away from where we are at the moment. So we lead in product. IES is recognised worldwide as being one of the leaders in this area. Right? The American press recognises us as the leaders in this area. But there's other things in Britain as well. You've got Strathclyde, you get ESPR, you get other, and I hate seeing the words with competitors called TAS and Design Builder and things like that. But Britain actually is way ahead, not just in product, but also in use. And the kind of way that I look at it is the fact that I was at a recent ASHRAE conference, and And they asked the audience of about 200 people, how many people in this auditorium only have, or are the single user of simulation software within their company or within their office? And about 80% of the people put their hand. Okay? That's not the case in the UK. In the UK, most people have multiple people using software. They use it effectively and they use it for low energy design, which is not really done in other countries. We don't use it in the same kind of effective way. So not only just leading product, we lead in use as well. And to some extent, and I'll say something to my co-host here, when in things like the States, it's companies like Buro, Happold and Archtecture that a lot of the top architects really love working with, because they bring the British way of the consulting engineer working well with the architect, whereas in America you don't see that kind of thing. In many other countries, the engineer doesn't provide that kind of services. So it's quite a bit of differentiation in that way. But simulation, I would think, also helps them provide that kind of service. There's big issues about, and I think this is going to come to the fore over the next little while, talk about the design model against the operational model. The design model is what you get to design the building with, and there's a lot of people say, but when you actually design the building, it's not the same as the design model. And I think people need to understand that they're two different things. The operational model needs calibrated, it needs changed, converted to be where that actual building is, and that's an area with which is quite important to go into. Also accuracy, it's trying to get the model data right. How when you're designing a model, when you're putting a model together, do you know there'll be the exact number of people in here at this time, what the climate conditions are? You can't. And from an operational point of view, if you can get the information right, you should be able to do that. And if you do that, you can get a more accurate answer. So we need to look at how we get model data both at the design stage, but also we start to look at how you operate the building. But also you've got to get the algorithms right. And there's also lots of research and effort needed in that kind of area. So there's still some issues with simulation, but it's getting there, and as I say, Britain leads. But why do we need building simulation? Okay? Other than trying to design a building, get an airplane, I think the other thing is the lack of building physics knowledge. When you're starting to look at a low energy design, you've got to understand a little bit of building physics. And that's very intimidating. A lot of people haven't taught that in college and things like that. But the role of simulation is to try and give you information in such a form that helps you understand what the building physics are, so that you can then make a more informed decision. Obviously, the more effort you make in that kind of front, the better, the more value you get out of it. Another thing is there's complex procedures. Pre-am, Part L, every other country's got their equivalent. You've got Archtecture+Design, you've got Green Mark in Singapore and things like that. So these are complex procedures. So how can you use these and how can these become more effective? Simulation plays a major role in that. Also the fact that at the moment there's not enough experience in good sustainable solutions. And this isn't something we can evolve over, sort of a couple of centuries to get this right. With climate change, and climate change is coming, and everybody says it is coming, right? We need to do something fast. And again, the role of simulation is to provide you with information that helps you make better decisions. But because of the sort of inexperience in sustainable solutions, it means that the market's immature, and that immature market leads to greenwash, leads to people giving disinformation, because they've got a product to sell, they're going to sell you something, and you don't really know, you're not sure, it sounds good, it sounds right, but it's not right. With simulation, you're getting back to be able to optimise and verify what you've got, you can test things out. But as regulations become stricter, the demands of understanding what's going on in there so you can make the right kind of decisions becomes much, much greater. And again, that's where simulation have a big impact. And also the construction industry requires a myriad of solutions. I'll come back to that later on. So these are just some of the problems that we need to kind of address. So what we've been doing as a company is looking at this, and we invest a great deal in R&D. About a third of our expenditure goes into R&D. And also, we try to get external funding and external R&D funding thing. So that pays for a lot of things that we do, but what we do with it is innovate and do as much innovation as we possibly can to try to get simulation used by the mass market. Okay, try and get as many people using. So we've gone from we've got free products. We've got a free product that sits on things like this thing. We've got another thing that we call VWare that people have been downloading. There's tens of thousands of downloads of this. I'm not saying tens of thousands of people are using it. We've got tens of thousands of downloads of it. people using free software, free building simulation software, but we've done them away and they don't know that's what they're using. They don't know they're using simulation, they just think they're getting an answer. Okay? But so it's looking at that, how can we address things like this? So what we've got is a suite of integrated simulation tools. We had those that are familiar with BIM and the kind of concept of BIM, we had that 15, 16 years ago, right? Long before people started talking about BIM, long before people started talking about sustainability, we were doing this, we were working towards this kind of area. We've developed things called navigators. Navigators make the whole process much easier, much quicker for people to go through simulations. So it's doing things like that. Also, we've got complex, HVAC systems get very complex. We've done things called multiplexing, making these complex systems much easier, much more effective to do. And I mentioned one of the levels of software. We've got 4 levels of software that's aimed at different people's use. And one of the levels, VE Gaia, has been starting to be picked up with a lot of the main architecture practice around the world. People like Gensler and H.O.K. have actually started to go through the whole company. Right? So we're trying to address many of the issues that I was saying that there's a need for. Also, we have consultants in there. The consultants not just do the consultancy work for people, but they also do the support and training. So you get people that know the software, and again, trying to do that. But it also leads into another area we think is very important, is education. And we've got something we call IS faculty, and they do a lot of the education. A lot of the things we'll do is free training and free explanations of things like building physics. So, for example, we do training courses for architects in building physics to allow them to kind of get a better understanding and feel less intimidated when they're doing simulations, or they're getting simulation results from an engineer. So basically, we're kind of coming to, when you look at the whole market, building simulation's got a major role. It's got a major role for virtually everyone, right? So you're talking about manufacturers saying, look, I want to get a product into market, how do I do that? Or else I need a sales team to kind of explain what's going on. Or you're maybe talking about a building regulatory system, like LEED or GREEN or something, that's saying, how can I make that system more effective? How can I do that? Or you're talking about investors saying, look, I need to do some due diligence in this. Or maybe say somebody that's doing a carbon reduction commitment scheme. All of these things, people need to be able to get an answer. We need to be able to look at something. And that's what building simulation is really about. It's got the capability of addressing those and giving people kind of answers. So in some ways, what building simulation provides is integrated environmental solutions, right? So what you're really saying there is the fact that if you want to if you're doing a thermal analysis, you can't do that without thinking of the impact of lighting, right? Or how would that affect occupant comfort, or how would that affect the airflow in the space. All of these things are integrated together, and they've got to be addressed in that kind of way. And that's the kind of key thing. But where you kind of move from there is into the bigger picture. And this is the bigger picture we're looking at trying to address. So what we're saying is, from the kind of master planning stage, you build a model, you start your model at that stage, you start to build it, you get the feedback information, you start thinking about what you do in terms of the contact with utilities, the whole urban design aspect and things like that. You take that and you then say, right, let's take individual buildings and pass it out to people. You then go through the place where you do the concept design, schematic design, detailed design. That's where most people use our software at this moment in time. But then when you come to the detailed design, you've got a great model of the building. That's the design model. Convert it into the operational model, you can start doing the commissioning and then start to look at the operation of the building and start to control the building from there. And once you start controlling one of the buildings, you then map it back to the master plan, you bring the rest of the buildings under that control, you can then start to control the community and start to make it as energy efficient as possible. And then from that, you match up to the master plan and you've got a total solution. So what we see is building simulation, building the whole life, going through the whole life of the city or a community, but in that way maximising the sustainability, minimising energy consumption, and creating